Hey everyone. This handout is titled Unit 1, How to ID Word Problems. So the questions I give you on quizzes and exams, you can call them word problems. They have a narrative description of what the question is asking. They aren't just an equation and the numbers you have to plug in. So you do have to figure out what kind of problem it is. And for the different types of analyses that we've learned so far, this diagram is a decision tree to help you figure out when you're reading the question what kind of analysis you're going to do. All right, so at the top, it has the question, is the measured variable? And then with arrows below, one side points to categorical and the other side points to quantitative. All right, so if your variable is quantitative, then you're going to be given in the question um, either mu and sigma or x bar mu and little n. All right, remember we have two situations. Either we are looking at a population where we actually know mu and sigma already, or we've taken a sample. So if there's a little n, a sample size in the problem, you'll also be given an x bar, the mean that is calculated from the sample. So remember, for now, we have to assume that we know sigma, so you have to be given that as well. This situation is artificial. All right, so on your quantitative variable side of how to figure out what kind of problem you're doing, you look at the information you're given, and the easy way to tell them apart is if you're given a sample size, right? So then you're going to use the equation to find little z that includes that sample size, which is z equals x minus mu over sigma divided by root n. All right. If you don't have a sample size, you're only going to be given mu and sigma, then you use the simpler equation, little z equals x minus mu over sigma. And then you will use the standard normal tables to find the area to the left or the right of z for all formulas that have the z variable in them, all right, on our quantitative side. On the categorical side of our diagram, you also are going to tell what's happening based on what information you're given, right? So when we talk about word problems, we say, oh, there's all these words in here that are confusing up the whole thing, right? So one of the things that's really helpful is to convert what's written in the problem into your variables. So if the question explains you've taken a sample of size something, write down on the paper next to it, little n equals whatever that's given. So it says if you've taken a sample of size 10, actually write down little n equals 10, right? Then you know that you've got a sample size in your information. And when you're looking for it later to plug it into an equation, you'll find it. All right, so on our categorical side, we're going to be using the binomial distribution as our basic distribution when we are looking at categorical data. So the simplest thing that you might be asked to do is just to find an estimated proportion. We took a sample, um, and there's a certain number of successes that we have found. All right. So if all you have is the sample size and the number of successes, little x, then you are only able to find the estimate of the proportion, little p hat, which equals little x over little n. All right. Find the proportion. All right. So it gets a little more complicated if we're answering questions where we're given a sample size and a little p. And in this case, little p is going to represent our proportion of successes. And this is the case where we're looking at samples of a given size that have a set proportion. And the result, or what we end up with, is actually the distribution of all the possible different outcomes of little n and how many we get or how many we should get given that probability of success. All right, so if you're given a probability, that's going to be your little p, and a sample size little n, but this is going to be a sample size that we're taking repeatedly. All right, and so that is going to lead us into the binomial distribution setting. All right, now if we have the binomial distribution setting, then when we're given little n and little p, we also need to look at little n because there's two different possible things that can happen if we have the binomial distribution setting. So there's an arrow on this diagram pointing to the left that says if little n is less than 20. And there's an arrow pointing to the right that says if little n is greater than 100. You don't have any information about what to do if your little n is between 20 and 100, and that means that I, your thinking professor, have to not give you any questions on your exam where that is the case. All right, so what we're going to do if n is less than 20 is we're going to use the equations for the mean and standard deviation of a binomial distribution, which are mu equals little n times little p, and sigma equals the square root of the quantity little n times little p times 1 minus little p. All right. We can also, if we are asked questions about probabilities, we'll use the binomial distribution table. And if you're looking for the equivalent of an area to the left or an area to the right, what's the probability of getting 5 or more successes, for example, then you're going to add up the probabilities from that binomial distribution table for 5, 6, 7, however many you have. All right. So the arrow going the other direction, if n is greater than 100, it says use normal approximation to binomial distribution. All right, so remember that our sample size is large enough, that is, if it's over 100, then our binomial distribution looks close enough to the normal distribution, and we like the normal distribution. So we're going to use it, right? But its mean and standard deviation of that normal distribution are going to be based on little n and little p. The normal approximation to the binomial distribution has a mean mu that is also equal to little n times little p. However, its standard deviation is the square root of the quantity little p times 1 minus p divided by n. So once we find the mu and the sigma, we're going to use the equation z equals x minus mu over sigma, and little x will be just the same as in a standard normal distribution problem. It's the thing, the value that we want to find the area to the left or to the right of. All right, so overall, this diagram asks the question, is the measured variable categorical or quantitative? So that's the thing you need to evaluate first. If it's quantitative, you need to know whether you're in a scenario where you have taken a sample and you have an X bar, or if you're just looking at population data. There's two different little z equations. You need to know which one to use. On the categorical side, You need to know whether you're just being asked to find an estimated proportion or whether you're being given a little n and a little p, probability of success, in which case you're in the binomial distribution setting. If your sample size is small, you're going to use the binomial distribution table to find probabilities. If the sample size is large, over 100, you're going to use the normal approximation to the binomial distribution. So you'll need to calculate the mean and standard deviation of your normal approximation, and then you can use the z equation. All right, I hope this helps you.